Hey everyone, welcome back. Let's solve today's Leetcode daily challenge problem. So the problem name is Detonate the maximum bombs. After reading this name, you will think that the problem can be hard, but after my description, you will see that the problem is very easy to solve. Okay, so you need to have some predefined. I'm not giving the hint now. I'm just describing. Then I'll give the hint how you can solve this. So before reading, I'll just describe it. So you are given some bombs. So each of the bombs are, this is a bomb and there's another, this is white, this is another bomb. So they are bombs. So from here we can see that this is bomb 1, and this is bomb. So you will be given some bombs, and all of the bombs you can see from here. This is a coordinate system, and given this figure, graph figure. So this this is a coordinate system, and from here this is 0, and then this is 5, and so what will be this will be 6. So the x coordinate of this bomb 2 will be 6, and what will be the y coordinate? The y coordinate will be 1. Also for bomb 1 we can write that the x coordinate is, this is 1, this is 2, so the x coordinate is 2 and the y coordinate is 1. Now as each bomb is a circular bomb and they have a position, and the bomb can have a radius where its frequencies can travel. Okay, it has a range. So how can we define the range? The range is defined by its radius, and the range is colored in circles. So this is the range of this bomb 2, which can be defined as r is the radius, and for this is 4. And for this yellow, for this bomb 1, the radius is 3. So we can see from here that each bomb can be identified by 3 values. Okay, so they are x1, xi, then yi, and then ri. Okay, so for each bomb we have these 3 values. So the input will be given like this, that each bombs are denoted as xi, yi, ri, where xi and yi are the x coordinate and y coordinate in the location, and ri is the radius. Okay, so from here we can see this is the radius. So this is the pretty much description, and from here you can see when a bomb blasts, it causes a frequency, or it causes a shock wave. In real life you can see that when a bomb blasts, it causes a shock wave. So if this bomb 2 blasts first, its shock wave will cover this bomb 1, right? So it's inside, or it's already in this shock wave range. So based on this shock wave, bomb 1 will also detonate, right? So if we detonate bomb 2 first, it will also detonate bomb 1. But if we detonate bomb 1 first, then its shockwave radius is 3. So it won't be able to detonate bomb 2, because its bomb 2's coordinate is out of the radius of bomb 1. So it won't be able to detonate bomb 2. So the question doesn't ask which bomb should we blast first. The question actually asks how many maximum bombs can we detonate. How many maximum? So you can see from here, if we detonate bomb 1, we detonate only one bomb at most and maximum. But if we detonate bomb 2, this shock wave also detonates bomb 1 automatically. So we will have 2 bombs detonated. Okay, so in this case, if we detonate bomb 2, then the answer will be 2. 2 means the total number of bombs. So stating from here, you can see that this is the maximum. It's stated as maximum number of bombs. So when you see a maximum or minimum in a problem, you first go and think about a DP problem. But before thinking this problem as a DP, you should try and understand and try and think how we can resolve this problem. If we can resolve this problem in a basic recursive problem, or can we connect somehow, can we connect the bombs somehow or something. So let's see how the detonation works. I'm going to give you a hint now, and in this hint I'm going to describe how this happens and how the bombs are detonated. Okay. So we can see from here we are showing two bombs, which is this is C1 bomb and this is C2 bomb. We have marked the coordinate as C1. The center of bomb 1 is C1 and the center of bomb 2 is C2. The range of bomb 2 is shown here. This is the range. Let me mark it. So this is the range of the bomb. Okay. So this is the range of the bomb, and this is also the range of the bomb 1. So these data are given. We are going to learn some mathematics and geometry first, then we are going to solve this problem. Okay, so first we need to understand when two bombs are detonate. So two bombs, from here we can see, we just determine this as two circles. Okay, so two circles are separated. How can we identify, how can we calculate the distance between these two circles? From here, the distance between circle, the distance is distance. What's the distance? The distance is C1 C2, which is the center distance, the distance between the center. These are the Euclidean or Cartesian, these are the Cartesian coordination system, and this is the Cartesian x coordinate, y coordinate in Cartesian system. So from we can calculate the Euclidean distance between these two centers. So the Euclidean distance, if this is x1 and this is y1, and if this is x2 and this is y2, then we can easily write the distance. We can calculate the distance of a straight line is x1 minus x2 whole square plus y1 minus y2 whole square. Yeah, this is the distance of a straight line, right? Now yeah, this is the distance of a straight line, and we also have the radius. Now we need to think, we need to see how two circles can be in the range, can be out of the range. So we can have three types of situation, three types here, or three cases. Let me write this in three cases. They do not meet with each other. So in this case, C1 and C2, the distance of C1 or C2, the distance would be the straight line distance. The straight line distance is this one. The straight line distance between two centers will be, the straight line distance will be greater than the radius of the circle. So radius of any of the circle, it will be, or it will be C1 C2. If we are first calculating from C1, we are considering from C1 if its range, it's inside the range of C2 or not. Then for C1 we can see from here, or for C2 we will calculate for R2, right? So this way, I think you understood this, that yeah, for when we are considering circle C1, we are calculating the distance if circle C2 is inside the range of C1. For this case, we are actually calculating the straight line distance, which is C1 C2, and we are checking if this is greater than R1. This is greater than, if this is greater than R1, then they do not meet with each other, they do not collide. Okay, so this goes through case 1, and now we can write case 2. So in this case, C1 to C2, the distance will be equal to R1, for if we consider this first circle, and if we consider for second circle, which is C2 to C1, this will be equal to R2, also equal to R2, because they just meet here. So they meet in their tangent line. Okay, so the both of them has same tangent line, and that's why they meet. So we are denoting for C2 is C1 to C2. Then there's another case, which is case 3, and the case 3 can be, so in this case this is C1 to C2 is less than R1, also for C2 to C1 is less than R2. Now these are the cases when two circles can collide. Now what happens, what will happen, which case do we consider in this problem? So we cannot consider this case. This is not something that we can consider. So we cannot consider this one, we cannot consider this one, we cannot also consider this one, because what will happen is that we must know that case 4, this is the special case for this problem, that there's a radius or there's a circle like that, and there's another circle which goes in the center, which has this center to go, yeah. And we can see this is the center, this is the center which is the C2, and this is the center of this first circle which is C1. So from here we can see, be careful to know that you can see this is the distance, right? So this is the distance. So the distance is, so C1 to C2, this distance will be, if we calculate from C1, we can see this distance is out of bound of its region, right? So for C1, if we calculate for C1, I mean C1 means the bomb 1, this is the bomb 1. So we are actually determining for bomb 1. So for bomb 1, we can see the C1 C2 is greater than its radius, which is R1, right? This R1, which is this R1. But for C2 its radius is R2. But for bomb 2, when we are determining for bomb 2, C1 C2, this will be less than or equal R2, right? Because we can see not less than or equal, in this case it will be equal to R2, right? So R2 is the radius from C2 to its range, and we can see this is in the tangent or the lines, the circular line. This falls into the circular line of bomb 2, which is its shock wave radius. So it falls into this. But if there could be another case where we can write, so this is the case where we can see that detonating bomb 2 will detonate bomb 1. But there's another case which is, you can see from here, this is the case, and in here suppose this is bigger, and it's inside, the radius is inside. So here the circle, the bomb 1's center falls inside the range. In this case this is R2. So in this case for bomb 2, C1 to C2, this will be less than radius R2. You can see this distance, this circular distance, you can see clearly that this circular distance from this straight line distance, sorry, not the circular distance, this is the straight line distance from C1 to C2, this will be less than the radius of this bomb. Will be less than. So in all the cases we will consider only C1 and C2 less than or equal R1, R2, or the circle we are currently determining for. Radius of the circle we are bomb we are currently determining for. So this is the condition for detonating. So along this time I just mentioned how a bomb can detonate, the explanation. Now we will go to the understanding how we can fix this. Let's think, if a bomb, let's see, this is a bomb, this is bomb 1, let's just mark it as B1. Now bomb 1 detonates bomb 2, so we can have let's just have connection here. Okay, this detonates bomb 2. Then there's another bomb which is bomb 3. This does not collide with any of the ranges of these bombs, so we don't connect it with. So in this case we see that we only maximally detonate 2 of the bombs. Do you think where I'm going here? We are actually moving this problem into a graph problem. So how we are giving this as a graph problem? If a bomb detonates, here we can see that B2 detonates B1. So for this case or for the example case, let's just go to the example that we have seen here. Let's just go, this is the example. For this case our image will look like that. We have this bomb 1, we have this bomb 2, and we have this bomb 1. So detonating bomb 2 will detonate bomb 1. So we will have an edge from bomb 2 to bomb 1. Okay, so this is how. Let's see another example. Here we can see we have a lot of bombs here, so let's just mark them here. So yeah, which one detonates which one, that's a tricky part. So here we can see that bomb 2 or bomb 4 will detonate a lot of bombs, right? So yeah, what we can do from here is that if we first detonate bomb 0, this is the bomb. If we first detonate bomb 0, you can see from here, this is the bomb 0, and if we detonate it, it's in its radius bomb 1 and bomb 2 are in. So bomb 1 will blast, and yeah, bomb 1 will blast, then bomb 2 will blast. If bomb 2 blasts, the bomb 2 in bomb 2's radius, there's bomb 3, and bomb 3 inside of bomb 3's radius, there's bomb 4. So all of the bombs will blast. But how this happens? So what is the relation? So we have like bomb 1, this is bomb 1. So bomb 1 is 0, this is how they are marked. So detonating bomb 0 will first detonate bomb 0, and detonating bomb 0 will detonate which bomb? So this will detonate bomb 2, and bomb 2 will detonate what? Bomb 0 will also detonate bomb 1. So bomb 0, because it's in the radius, so it will also detonate bomb 1. Okay, so here it is bomb 1, it will also detonate bomb 1 and only 2. Then when bomb 2 is detonated, bomb 2 will also detonate bomb 3 and bomb 1. So we have connections with the bomb 2 will detonate bomb 3, and also bomb 2 will detonate bomb 1. From that we have connection. So this is how we can connect. And then bomb 2 will detonate bomb 3, and bomb 3 detonating bomb 3 will detonate bomb 4. Bomb 3 will detonate bomb 4. Then bomb 3 detonating bomb 3 will also detonate bomb 1. So there's also a connection from bomb 3 to bomb 1. Yep. So this is how they are connected, and this is how we can reduce this problem to a basic graph problem. Now how we are going to solve this? How can we solve this? Does this problem has a solution, or does this graph has a solution? Let's try and think. Suppose, yeah, what happens? We have started from here, we have started our journey from here, then we go to bomb 2, then from bomb 2 we can go to bomb 1, or we can go to bomb 3, yeah, then from bomb 3 we can go to bomb 4. This is like a traveling salesman type of problem, and this way we have traversed all the vertices, we have gone to all the vertices. So this is kind of a traversing type of problem, a graph problem and a traversing type of problem. So as it is a graph problem and a traversing type of problem, what algorithms or what approach can we take here? As this is a graph problem, when some graph problem comes in, we will first think DFS, BFS. We'll first think of DFS, then we will think of BFS, then we will think of something else, but first we will think of DFS. Now can we solve this in a DFS way? Thinking for B0, we will add B2 and B1. Then at first we will go to B2, then before looking for B1 we will also check for the children's or connections of B2. Then this way this will happen. So how this solution will happen? We will use a DFS. So when we are in a node, we will start calculating. So let me redraw it clearly. So this is just a simple graph, and we will be using DFS in here. So for each, in this case, for each node, we will be doing DFS and calculate how many nodes can we reach. How many nodes can we reach? How many? Remember, how many from one node. So we are first starting from here. From here we can reach this node, we can reach this node, and we can also reach this node, and as we have reached this node, we can also reach this node. So all of the nodes are reachable. But if there were another node, this one, or another node, this one, and another node, this one so let's see if they are connected this way, and this one has connection with no one, this one has no connections with it, or this one has connections with this one. So what will happen when we are in this node? This node doesn't have any in direction or in path here, and these two nodes doesn't have connections with this. So what we can see from here, that we have managed to actually detonate this bomb, and this and this one bomb, but we couldn't detonate this one because it's out of range, this one is out of range, this one is out of range. So using DFS, we iterate for each bomb. Yeah, oh, there's another thing. So for this case, we have started from here, we have started from this node. So this was our start node. Similarly, we will start from any other node. Let's see what happens if we start from here, from start. This is a start node. Let's see if this was the start node. Let's just remove this circle, this remove this and this. Yeah, now our start node is this one. This is our start node. From here we can go to here, yes, we can go here, then we can go here, yes, we can go here, then from here, yes, we can go here. These ones can be detonated, but we can see from here that these two, this one and this one, are not reachable from this node. From this node we cannot reach this one, and we cannot reach these nodes as well. So what if we start from here? We see that we can detonate 1 2 3 4 bombs. Okay, but previously, so for here we can detonate actually 4 bombs, but previously when we started from here, we could detonate this one, 2 3 4 5. We could have previously we could have detonated 5 bombs. So our answer would be, our maximum would be 5, because this is the maximum we can get. So this is how our approach will work. This is how our problem becomes a DFS problem, and this is kind of like a traveling salesman type of problem, where a salesman goes to each of the vertices. It's a similar problem, not the actual problem, but it is more like a DFS problem. So let's go into coding and show you how this can be solved. So this is the solution of this problem. So initially you can see from here that we have kept n as the bomb's length, and for each bomb we need to iterate. So for each bomb we take the bomb, and we need an array to store the bombs that we have seen. We need to store them. Then for the current bomb we have added true. Then for each case we will be running a DFS on that bomb and on that path, as you can see in the graph we have discussed. So we passed in the bombs, the index, the current index, and the scene, and the detonate. When we are in a current bomb, this current bomb will be detonating, so we will keep that in mind. So next, so next we are going to, we could also not pass this here, but if we can also pass it, it doesn't matter. So in our DFS we have, this is straightforward, this is the bomb index, this is the scene, and this is the detonate. So from we get the current bomb. Then for each other bombs we check if this is the same index, we do not continue, or if this bomb is also already seen or already detonated. Seen means actually already detonated, so if this is already detonated we don't need to consider it. Then if it's not, none of these condition met, then we will check for it, and we will store the x1, the center x coordinate, center y coordinate, center and the radius of our current bomb that we are for determining, and the bomb we want to consider for the other bomb. Then we take this and we calculate the difference, the coordinate x difference and the y difference, and then we check if the radius, if the radius is greater than, as you can see here, this is what we are implementing in the code, that if the radius, if this radius is greater than or equal dx into dx plus dy into dy. So this is what we are calculating here, if that radius. And why we have used r1 here? Because we are considering for our current bomb, the bomb that we are referencing, and the other bomb that needs to be detonated within it. So the other bomb, either whether this bomb 2 is in the range of bomb 1, that's why we are considering bomb 1 or its radius, only its radius, not considering the r2. When the loop iterates and comes for the r2, we will then check for r2. It will automatically check that. So as we have, if it is satisfied, if this condition is satisfied, then we will mark scene of I. Scene of I means the bomb that we are currently referencing for, and it will be true, and then we will be calculating for its children, and we will be going through a DFS, and yeah, we will be passing this one. So as I mentioned, we don't need to pass this one. We could also write, we could also ignore this, and we could also just remove this here. We could also just remove it here, and we could also just here include the detonate equal 1 and check whether it's possible. Yeah, we could also write this, yep. So this way we can also solve this problem. It doesn't matter whether we pass it, because at first I passed it and tried to check. So let's submit it and check how much faster it is. So from here you can see that the problem is very fast. It runs, it beats 85%, and the memory limit is also good. It's not bad, because yeah, this is a fairly reasonable solution, and I think it was good. I hope yeah, initially what I did wrong was calculating this to be long value. You can see from the problem description that it is said that the bomb's length is low and it is 100, but the thing to consider is that x1, the coordinates or the radius, the values can be 10 to the power 5. So when we multiply them, it will exceed like 10 to the power 5 into 10 to the power 5. It will be a long value, so we need to consider and we need to be careful about that. I first got a wrong answer because of that my answer or my solution wasn't completing, because the variable here I used int, or I didn't convert in long, so that's why this I was getting wrong. But yeah, this is a very good problem, and I hope you have understood what I was saying here. And if this video was helpful, please like, comment and subscribe. I don't share my videos anywhere, so yeah, I hope this was helpful. Stay connected for more Leetcode videos like this. Thank you.